Hello, everyone. Great to be here to talk to you folks. Thanks to the Upgrad team for giving me this opportunity. So today I'll be talking about product improvements using data science. The way we'll go about it, so I have certain slides just to walk you through some of the learnings that I've had. We'll take around 60 to 70 minutes in presenting that, and then maybe we'll have a short Q&A session at the end, right? And the agenda will look something like this. So I'll briefly introduce myself. We'll talk about data science, a little bit of introduction. Why is it important? How does it touch different parts of the tech industry today? Since I'm from an e-commerce domain, just to give you a flavor of how AI ML is being used across different parts of the e-commerce ecosystem altogether. Uh, then we'll switch on to understanding the process of building an AI ML product. What is the journey of building it? Who are the different stakeholders who get involved in that? How do they interact with each other? Understand that a bit in depth. We'll take certain examples from the industry, kind of mini case studies to kind of help understand the concepts a bit better of while building an AI ML product. Then briefly, I think, which is a general kind of query which comes up in people's mind when they start taking up AML, right? When to use AIML versus when not to use AIML, right? So we'll address that a bit, kind of demystify that piece a bit. Lastly, we'll take one good example around recommendations and kind of go a little bit more in depth and understand the nuances of how recommendations works in different industries using AIML. Briefly kind of touch upon that. And then we'll conclude the session by discussing a few things which as a PM has been a great learning experience for me over the years. Like what are the challenges I've faced and what are some of the learnings and how do you mitigate the challenges and risks that come associated with building a AIML product, right? So that's going to be the high level agenda. So without wasting any time, I'll just move on. Feel free to like put your questions in the doubt section. I'll be checking it every couple of minutes or so and try to resolve them. So before we begin with the main content, right, a little bit of introduction of myself. So I think Sankar would have already touched upon that. So I started off my career 10 years back as a software developer. I graduated as a computer science engineer, worked as a developer for 4 years, building both backend platforms as well as customer-facing products, internet products in the edtech space. Did my MBA from IIM Bangalore and then started my product management journey with Flipkart. Within Flipkart, I've done multiple product stints, done a bit of everything, I would say. I've been working primarily on the customer-facing funnel side. Lately, I've been working on the marketplace side. By marketplace, what I mean is the seller side. So if you think about Flipkart, there are at a very high level, there are three different orgs within Flipkart. There's the customer funnel, there's the seller experience platform, and then there's the fulfillment leg, right? So I've kind of spent most of my time in the first two pieces. Leveraged data science completely throughout my product journey in solving for various kinds of problems, customer problems, business problems, and all of that. Build customer facing products which actually optimizes the Flipkart funnel and helps improve our business. So that's been my journey. I'll just take another couple of minutes to kind of take you through how I got into the data science journey and what kind of products I built and how did they help Flipkart in its overall ecosystem, right? So so starting off, right, at some point of time, we realized that when I was leading user-generated content, I was building products around user-generated content, right? The first thing as a challenge that we faced is what do you mean by user-generated content? Any type of content which is contributed by our buyers, like be it customer ratings, reviews, any survey responses, any kind of implicit data that we generate about their profile, their demographic data, and everything, right? So one of the challenges that we're facing at that point of time was as the scale of our content was increasing, how do we keep moderating them? How do we keep reviewing them so that the right content goes live on the website, and content which is not as per our guidelines, let's say it's a profane content, cuss words being used or whatever, how do we filter them out, right? So it was a challenging problem to solve from a manual perspective, and we used to do it manually using operations team who would manually review each content and kind of approve or reject it, right? It is not scalable enough, so we started building data science products around it. So the whole piece was around how do we automate some of the existing business manual process that we have using data science, right? But data science, if you think of it, right, it is not restricted to just automation. We can actually build intelligence. We can create customer delight using it. Like, for example, one of the features that I would be talking about in the next couple of slides during this presentation is something we call as aspect ratings, right? Where if you look at Flipkart today, if you go to a product in electronics or somewhere, right, you'd see ratings around different product aspects. Like in furniture, you'd see a durability rating. In lipsticks, you'd see a smudge-free rating. In say air conditioners, you'll see a rating around is it noise proof, how is the energy efficiency. So it is not the problem that we're trying to solve there is not automation per se, but how do we create customer delight? How do we take the experience to the next level and solve for customer needs, right? So data science is not just about automating processes, but we can actually build features that were not possible earlier using data science and create customer delight, right? But it also lately the problem statements that I've been working on, right? Some of the last two pieces that I mentioned here in this slide, they are about also solving some of the core business needs. For example, today, one of the teams that I'm leading today is selection design, right? Where the problem selects supply gaps in Flipkart. So like today, if you look at it, like we don't sell everything that is available in the market in the offline world. There are products which you would not find on Flipkart, you can find in the offline world or maybe on other platforms, right? How do we so this is one kind of problem, right? Second is like there are a lot of cases where users come to Flipkart, search for different products, but they do not get it, right? And so how do we identify these opportunities? How do we derive these insights and try to work with business teams, deliver these insights and help them build the selection in the right way, wherever we need to be present, where there's demand, where their customers need something from us, right? So if you look at the data science journey, right, it's just not about automation. You can actually create customer delight. You can also solve for some of the core business needs, and all of these were probably not possible earlier when data science didn't exist, right? So yeah, this has been this is in my story about data science and how we leverage data science in Flipkart. Now jumping on, right? So the core part of it, right? If you look at the industry today, data science is virtually everywhere, right? And this is just a screenshot of the Flipkart homepage, right? I mean, it's very hard to imagine how can the homepage be designed without the existence of data science, right? Just to give you a sense of how this operates, right? We have millions of products selling on Flipkart. We have millions of users visiting us on a daily basis, and there are thousands of categories selling, and there are multiple stakeholders involved, right? As a PM, I want to optimize for customer conversion. So everyone who visits Flipkart, how do I make him purchase a product? How do I make him convert, right? Business has a goal of how do I increase the revenue of my category. If there is a business team, which is dealing with, let's say, sports shoes as a category, his objective would be, I have a sales target of XYZ in this month. How do I meet the target? How do I optimize my sales? How do I increase my profitability? Then there are partners like brands who are working with us who want to leverage our platform to create awareness about their brand. Like, let's say there's a new product which is launched, they want to market it and build audience around it, right? So there are multiple stakeholders involved, multiple choices in terms of products. There are users with different preferences and everything, right? And there are multiple business goals, right? Like I mentioned, there is profitability and GMV at one end, there's conversion at one end, and a lot of these, right? And how do we optimize for all of this, right? It's virtually impossible for a human being to optimize for all of this together, right? That's where data science kind of comes into play here. So we have multiple widgets here, like we have commerce widgets, we have non-commerce widgets, we have recommendations, we have recently searched, and multiple other widgets, right? So if I go back in time, right, at one point of time, this entire homepage wasn't that complex, and it used to be manually curated. There would be people who would come, kind of explicitly provide that we need to so and so widgets on the Flipkart homepage and so content on the Flipkart homepage, right? And then obviously it was not scalable, and it was not optimal, right? It is kind of a constraint optimization problem where you're trying to optimize for multiple business objectives, right? So then we went into a phase where the widgets, like what do we call as widget, right? For example, deals of the day is one widget. uh, uh, Explore based on your interest is one of the widgets, right? So there are widgets which are kind of manually curated and configured by merchandisers, but the content which gets shown within those widgets started getting automated, ranked, recommended based on our understanding of user preferences and all of that, right? Then today we are kind of in a phase where even the widgets are kind of auto-generated. Like everything, the entire homepage is probably most of it is manually generated, curated, ranked. Which widget needs to be ranked where, based on who the user is, based on what is the context. Are we approaching a sales season? Something, right? So many of these pieces are automated using data science, right? We have concepts like, for example, uh, how do we predict the CTR? How do we predict the conversion of a widget, of a content piece, right? So without data science, I can't really imagine how all of this would have been possible back in time, right? So honestly speaking, like if you look in any platform, like not just e-commerce or Flipkart, like look at content platforms like Netflix or any other thing, right? So data science kind of is present everywhere, touching each leg of the customer journey that we can think of, right? Um, so having said that, since I'm from an e-commerce domain, so we'll talk about some of the pieces that we where we apply data science in e-commerce. But so we know that data science is everywhere, right? But it's a very complex piece, right? And it's vast. There are a lot of concepts. There are different kinds of techniques like supervised learning, unsupervised learning. There are neural networks and all of that. So it's a vast space. It's a complex space. A lot of second thing, it's fast evolving, right? It's very fast evolving in terms of the techniques that we use, in terms of the data that we generate. We generate so much of data on a regular basis, right? And the kind of problems that we're trying to solve, right? So it's a fast evolving space, and keeping up with the space kind of virtually becomes impossible for many of us, right? So that's why it kind of makes this space much more interesting. And third is there are a lot of misconceptions. Like there are terminologies like DS, AI, ML, and a lot of people probably do not understand like what each of these mean. Are they substitutable? Are they different? Is there an overlap? Can I use them interchangeably? Or are there other concepts like the metrics and everything we'll talk about later in this slides, right? So all of this makes this piece a very interesting piece. But also we also understand that without having exposure to data science, probably impossible to kind of build our products going forward, right? And these are some of the queries that generally people speak about when I talk to them, right? How as a PM, how much of data science should I know? Like, I'm not supposed to build models, right? Data scientist is supposed to build models. So am I supposed to understand the models, right? How long does it take to build a product? So there are a lot of these questions that come up in everyone's mind, right? And during this presentation, hopefully I'll be able to address some of these questions, and maybe whatever remains will take up in the Q&A session. Right? So yeah, moving on. I'll just pause a while here and kind of check if there are any questions, anything till now. Okay, I don't think there are any, so I'll kind of move on in the interest of time. So yeah, so moving on, right? So since I'm from the e-commerce domain, I'll kind of want to give you a flavor of where all we apply AI/ML today in the e-commerce space, right? So starting off, right? So we have the buyer journey, right? As a customer, you come to Flipkart, you are looking to buy something, right? And the journey that you go through, you start searching for something, you're trying to find something. So there's a discovery phase, right? Where we're trying to show you the right products that you'll be looking for, where homepage, I talked about it, like it comes into play. If you search, right, you type in a query, some system needs to understand what do you mean by the query. Like if I search for, let's say, phones of brand MI in the range of 50,000 to 20,000. I need to demystify at the query and understand that phone is a category, MI is a brand, 15,000 to 20,000 is a price range, right? I need to tokenize and understand the query and then identify suitable products around it, right? Once you discover, then you go to the decision making phase, right? When you're exploring, you visit multiple products and try to make a decision in your mind as to what should you buy, what should you not buy. Like things like which size should I buy, or is this product good enough? Is the quality of this product good enough? Those are questions that we try to solve today using data science, right? Later on, moving ahead, like you try to check out, where also there are a lot of nuances, right? How do I There are a lot of sellers, for example, in e-commerce who buy and resell, because e-commerce we tend to get some discounts. So people buy it at a discount and then sell off offline or through other places, right, to make money, right? Which is just not the thing behavior that we want to encourage, right? Or there are address verification problem statements. Like for example, today a lot of addresses that people type in while filling in the delivery address are not well formed, right? Because someone would write key go behind this temple or something like that, right? So where because of way the geography of India works, right? On not all addresses are very well formed, right? So we try to understand resolve addresses so that we optimize our delivery promises and everything, right? In the post-order journey, right, once you've placed an order, we are very well aware of the customer support ecosystem, right, where today everyone started using chatbots to kind of auto-resolve some of the queries that people have in mind. Then there are certain core services that we build, right? For example, user profiling, right? Like for example, if I have to build recommendations, right, I need to know who you are, right? And that I try to understand explicitly as well as implicitly. You might tell me explicitly that you're of so and so age and all of that, right? But a lot of implicit nuances also we try to discover, right? What are your category interest, like which stores do you prefer, which brands do you prefer, what is your price segment looking like, are you a value conscious user or are you a premium segment user, right? So a lot of user profiling also gets done when we are trying to optimize our recommendations or our customer funnel, right? Moving on, right? So there are a lot of applications also in the seller journey. So if I talk about it, when we onboard sellers, how do we identify the right sellers to onboard? How do we verify the documents in an automated way so that the details are right? During listing, right? How do we make sure that the quality of listings is high enough, and how do we make sure high quality listings get enough amount of discoverability so that when people place orders, they don't get bad quality products, right? So we try to optimize for that. Then there is inventory management, right, where we try to forecast like what is the demand going to be in the future for a particular category, for a particular product, so we can accordingly kind of recommend sellers about how much to stock and all of that, right? And then there are growth insights. We try to where the objective is, like for example, how do we grow a seller's business on Flipkart, right? How do we help them price their products effectively? Can they use ads to promote their products and all of that, right? Then there is seller support, like similar to customer support. Then the third piece, which I talked about earlier, also is the fulfillment journey. Again, in fulfillment also, there are a lot of pieces where we leverage data science, like starting from where do we place our inventory, because we have like say delivery hubs, mother hubs, and like there is a supply chain network, right? Where do we place our inventory, in what quantum? How do we automate some of the processes that we have in our warehousing, right? How do we prevent fraud? How do we optimize the routes of the last mile routing of the delivery executives so that we are able to deliver most amount of products in the best quickest amount of time, right? So a lot of these pieces also get solved through data science. Also the last but not the least, right? It's also about solving a lot of stakeholder needs. Like to give you an example, right, we spend on marketing, Flipkart, right, on social digital marketing, physical marketing. How do you optimize the spends? How do you get the best ROI out of those spends, right? We have private labels, like we have Flipkart Smart Buy, like where we kind of brand and sell our own products, right? How do we identify what products to sell there? How do we differentiate our products from the rest of the supply that exists in Flipkart, right? What is the unique value proposition of products and present? So a lot of these pieces where we leverage AI/ML. So if you can understand, like it virtually it touches across every leg of the entire e-commerce ecosystem, right? So I mean, I hope we understand how critical it is, right? Now moving on, right? Let's kind of demystify and look upon how do we build an AI/ML product, right? What are the steps in the journey and who all are involved in that phase, right? So starting off, as a PM, the most important piece, right, is problem definition. Which is the most important part. As a PM, I think the most important role that we play is understanding the business context, understanding the problem, understanding the why of the problem. Why do we need to solve it? Why is it critical? Kind of discovering the customer need, right? I think that is where a PM spends most amount of its time in general, right? And in data science also, it's not very different. That's what you need to do. But along with it, when you're building an AI/ML product, there are a couple of more things that we need to do, right? And we'll look at certain examples later in a later slide. Is how do we translate the business problem into a data science problem, right? They are not the same. and I'll tell you why. I'll show you why in the later slide, right? How do we translate it into the data science problem? How do we build the hypothesis, right? What is my hypothesis? My hypothesis could be, for example, if I'm sending a push notification, right? If I'm sending it after 8 p.m. in the evening, the customer is most likely to click on it because you'll be free. He's out of his office hours, so whatever, right? That can be an hypothesis. We need to validate, and if it works out well, we need to optimize our push notifications campaign in such a way, right? So we need to build our hypothesis. We need to and validate and kind of optimize on that, right? The third thing, which is the key thing, is identifying the right metrics. Again, this is not very different from what a PM generally does, right? Identifying the right metrics and identifying the success criteria, because a lot many times what happens in data science is use data science products take time to get built because there's a lot of research and development involved, right? So because you've invested so much of effort, you would want certain amount of goodness, right? Certain minimum amount of goodness to come out of it, right? So how do we do that analysis and figure out that we need to get at least 5% of say conversion improvement, and anything below that probably doesn't justify the effort that I need to put in, right? So how do we establish the metrics, and how do we kind of clearly define what is the success criteria which is going to be like? So that's the first piece, and all of this is primarily done by PM. Like obviously data scientists can come in and share their opinion, but primarily the ownership lies with the PM. The second part of the process of building an AML product, right, which is the data exploration stage. And this is a shared exercise. This is a shared exercise between a product manager and a data scientist, right? Where given we've defined the data science problem, we identify how do we solve it. Excuse me. What are the data sets that we need to use? How are the data signals that we need to use, right? How do we transform the data? How do we take care of the data anomalies, missing data, or all of that cases, right? And how do we look at different customer segments, right? There could be different user segments, and all of them could exhibit different behavioral patterns, and the data could also show different nuances in each of these, right? How do we, because a PM is supposed to have full context on the business and full context on the domain, right? He's the most informed guy to make hypothesis or build certain awareness around this, right? He already has some insights into what are the different user segments and how do they behave differently, right? A data scientist might not have that kind of an exposure. He would obviously might build all of that knowledge when he starts working on the data, but the more the PM shares this knowledge and makes it more interactive, the in the beginning of the process itself, you are going into a much more richer conversation, right? So this is the second part, right, where you identify features and kind of finalize them. The next part is the modeling and optimization bit, which is primarily run by a data scientist, right? And a product manager plays kind of a secondary role where he's evaluating and giving feedback, right? Where a data scientist would probably like build different models, use different models and techniques, and build certain things. He will validate it, retrain it, iterate upon it, and all of that. So which is primarily done by DS. Now, where does a PM come in here, right? And we'll talk about some of this later in the slide also. Is one in validation, in validating the output and kind of criticizing the model, right? Looking at it, being a devil's advocate to the data scientist, right? And second is making the right trade-off calls. A lot many times, what we have to understand is to data science, right? There are data inputs and there are models, right? Models might be great, but if you don't have data, good enough data, then also your output might not be looking great, right? So a PM comes in and makes the right trade-off calls and make the decisions in order to make progress, right? So validation and making the right trade-offs is probably the two things that PM kind of contributes to in this part of the journey. But as a whole piece, probably a data scientist owns this piece and is more accountable for. The next piece is, once the models are ready, how do we deploy it and how do we test it out in production, like doing A/B experiments to figure out if our hypothesis is right. Do we need to course correct and all of that, right? Again, here uh, it's more of a mutual exercise between the data science team and the engineering team, right? Because the data science model, maybe it's built in Python or something else, right? And it needs to be deployed. It needs to be made part of the core engineering stack that we have, right? So they need to interact. And as a PM, you need to facilitate those conversations, right? So an engineer and data scientist will work together to deploy it, kind of make it part of the core funnel. And the second piece, right, which is how do you build a fallback? How do you build a fallback loop, right? And have the right amount of feature flags. For example, data science could go wrong. Like probably it's not able to predict in a certain scenario because it's discovering some new data which it is not used to, right? So then we need to make sure that the product doesn't crash or doesn't kind of give out a failure scenario at that point. There should be a fail-safe scenario. There should be a fallback, right? And those fallbacks need to be defined by the PM. What do we do when the data science model doesn't work or it fails, right? Second is when you're doing an A/B experimentation. How do we test the A/B experimentation? A/B experiment. When do we conclude? Um, uh, like a lot many times during A/B experiments, what happens is there are like couple of main metrics and they might move in different directions, right? Then how do we demystify this? How do we take the call as to whether this experiment is successful or not successful, right? That is where a PM comes in handy. But again, that piece is primarily driven by data scientists and engineers. But again, PM kind of plays a secondary role here, and he needs to come in wherever required. The last piece of building a product, once you've experimented, let's say it's successful, then you need to deploy it in production and kind of scale it up, right? And in the scale up phase, both PMs and data scientists are less involved. It's primarily becomes an engineering task, right? Where they need to make sure that the model is in operations, the health metrics are looking well. The only thing where PM and data scientists come in here is keep looking at the right metrics to figure out if the performance of the data science model is continuing to be good or it has degraded over time. There are a lot many times what happens is like consumer preferences change or the kind of data that comes in changes, right? For example, like at some point of time, TVs used to be just normal TVs, right? And at a later point of time, we started seeing more of smart TVs. Or like take phones, for example, fingerprint sensors didn't even exist at a certain point of time, right? So everything kind of changes. Nothing in this world is kind of permanent, right? So as the data changes, your models need to learn through the new data and try to operate on that, right? So in most cases, the performance of models degrade over time, and the degradation is longer when the time is longer, right? Is more. So as a PM and data scientists need to keep track of it and identify opportunities or phases where we need to retrain and retest and redeploy the models. That is where a PM and data scientists come into play. So at a very high level, this is how an AI/ML product is built in the industry, right? Yeah, we'll now go over like certain examples, like industry examples, to kind of go deeper into some of these pieces that we discussed here. Again, I'll probably pause for like 30 seconds and check if there are any questions. Awesome. So let me just look at a few of them. I think there are 3 or 4. As a startup, how to proceed with AI/ML since not much of data is available in the starting years? Fair enough, right? I think this is not just a problem for startups, right? But it's also a problem for um, uh, mature companies, right? It's because a lot many times when you're trying to build a new feature, you do not have the data for it, right? So how do we start? I think it's generally termed as a cold start problem in the industry, right? So one, as a PM, you build certain hypotheses and you make certain assumptions, right? And you start off by testing those assumptions, right? You build products, you build models as per those assumptions, and using some rules as well, right? You say that to this user I'll show this, to this user I show this. Based on your assumptions, you kind of hard code something, you curate something and show it, and then through data you check if it is working, if it is not working, and then try to learn, right? So that's one way. And second, we have something called, generally in the industry, something called explore and exploit. How that works is basically, let's say there are recommendations, right? So we don't have any data in terms of what you like or anything, right? But then we kind of create certain sample data sets, sample recommendations, multiple different recommendations, and try to give it to different user segments and check what works, right? You basically identify multiple different ways of recommending products and just push it out to users and keep continuously validating the data, right? um, that's basically you're exploring multiple techniques, and over time you start gathering the data and exploit that data, right? The third, which is also critical, is, I think I'll touch upon some of these in the later slides as well, is a lot many platforms have an onboarding experience, right? If you look at Netflix, Spotify, everything, right? When you create a new profile, they ask you to share some of your interests, right? Which is again primarily to solve with a cold start problem, by not starting from scratch, but getting some preferences in the beginning so that I know where to start from, right? Um, so I think these are some of the ways. There are multiple other ways. If we have time, we'll go over it later on. Um, I hope that answered your question. Uh, um, okay, I'll go to the next one. Not so. sure what are we supposed to do. How do we convert a business problem to an AI/ML problem? I'll go over that in the next slide, so I'll park it aside for now. Talking about user profile and how AI/ML helped in it and what advantage did Flipkart make. Um, I think what advantage it made, it's virtually impossible. Right? It's so huge, it's so enormous, right? uh, Everything, right? When you do user profiling, you understand the user preferences, right? So when I do search, when I do recommend, I know you have an affinity towards this brand. I know that you are more value conscious. You probably buy in a smaller, lower price segment, but versus maybe like if I go to tier 2, tier 3 cities, they are more prone to buying a sub 500 range product. Versus when I go to a metro, maybe people are open to buying like 1,000 rupees to 2,000 rupees product, right? So there are multiple kind of dimensions where user profiling helps us and build a personalized experience for the user. So it kind of enormously helps the entire Flipkart funnel. It's hard for me to kind of quantify and tell that this is the exact advantage it made because it kind of cuts across the entire Flipkart journey, right? We'll talk about the recommendations piece later on. So maybe some of these questions can be addressed there as well. One last question: as a product manager in Flipkart, what are the top 4 or 5 statistical concepts that must be hands-on with? Is completely the responsibility of a data scientist. Okay. I wouldn't say that it's completely the responsibility of a data scientist. You need to understand the data, and if you understand the core responsibilities of a PM, right? Data is one of the most important things, right? So you need to understand the basic data, at least. I'll skip the last question maybe for later. Yeah, you need to understand and do some kind of analysis to identify like what are the broad patterns in the data. You need to but you don't need to model, you don't need to code, right? That can be left to the data scientist, but you need to understand and derive insights from the data. You need to be able to validate the data, right? Because there's a lot of data generated on a regular basis, and so to uncover the patterns, you need to be hands-on with the data, but you don't need to code or don't need to develop models around it. Okay, moving on. I'll probably take the rest of the questions later on in the interest of time. Someone asked a question about problem definition, right? Let's take an example. So this is one of the products that I was mentioning earlier, right? So if you look at the right screenshot, right, this is a snapshot from an air conditioner product, right? Earlier, and this was an industry first kind of feature which was launched by Flipkart in the e-commerce platforms. So earlier we used to just show a customer rating, right? And obviously that is not enough, and users need to know what is the cooling performance, how energy efficient it is, and all of that to make a buying decision, right? So the business problem that we're trying to solve for, if the user think of the user need, right? It's about how do I make the decision. In order to make a decision, I need to research about the product. Even today, people would go to YouTube, go to multiple other platforms, check it, customer feedback, look through some of the videos in YouTube, and get more knowledge about the product before deciding whether to buy or not to buy. In the offline world, you have a sales guy, right? You have a salesman who kind of explains you all of that, and you can share the needs you have, and then you kind of clarify some of these things, right? But in an online world where you do not have a sales assistant, right? How do you resolve that? How do you enable research to be done, right? That's the user need, and the business problem is obviously that how do I enable the user to make a decision in the most fast and convenient way possible, right? And there are multiple ways of doing that. One of the ways we defined through whatever understanding we had, whatever hypothesis we had, is let's build a target product, like the target product which we have here. Let's build a product which summarizes customer feedback at a product aspect level, right? Let's show the ratings summarized on each of these, right? And that was the target product that you're trying to build, right? Now this is the business problem, right? How do I convert into DS problems, right? That is where it comes in, right? So where if I break it down, the first thing that we need to do is identify which are the aspects in this particular product, in this particular product category, which are of relevance, which makes sense to the user, which is what the user needs to know. So that's one part of it. How do I identify the aspects, and how do I do it automatically without any manual intervention? The second is, how do I organize my feedback around these aspects, right? People write reviews today. A lot of people write a lot of things in the reviews, right? So how do I identify which are those reviews which are talking about, say, energy efficiency, right? So how do I organize all my reviews around these aspects? That's the second data science problem that we need to solve for. Third is sentiment analysis at a high level, right? So how do we, now we have reviews kind of organized across these aspects, how do we classify them into positive versus negative, right? And the fourth is how do we summarize all of this? Now we know that, like, let's say there are 100 reviews against energy efficiency. There are 50 of them which are talking positively, 50 of them which are talking negatively. How do we summarize it and so it as a rating or whatever way possible, right? That's based on the experience that you design for the user, right? So if you think of it, right, the user need, the business problem is how do I enable research? How do I make faster decision making possible? But the data science problems generate from the target product that the PM wants to build, because the target product here was how do I summarize feedback at an aspect level. The data science problems happen to be how do I generate aspects, how do I organize opinion, and how do I summarize opinion, right? So, and each of these four statements which I mentioned are DS problems now become individual pieces for a data scientist to solve for, right? So that's how we break down a problem. That is where, and this is not something which we obviously do in a non-data science world. In a non-data science world, it will break down into engineering deliverables. Here, it will break down into data science deliverables, right? There's an important distinction that we need to make here as well. There are business metrics and there are data science metrics, right? Business metrics are tied to the business goal that we're trying to achieve, right? Since here our business goal is enabling faster decision making, our business metrics would be how do I increase conversion. If you enable a user to make a decision as early as possible, it will lead to higher engagement, it will lead to higher conversion. If a user finds all information available with him for doing his research on Flipkart, he will obviously spend more time on Flipkart, he will not go to other platforms to do this research, so his engagement on Flipkart kind of increases, right? So business metrics are how to increase engagement and conversion, right? But for a data scientist, those are not metrics that you would build for, right? When it's like, let's say, working the first problem, right? Or maybe just say, let's say, like the third problem, how do I organize feedback into positive and negative, right? That is where a data science metric would be accuracy, right? If I manually look at a review and say that this is a positive review, it talks about positively about cooling, then the model, is it able to also predict the positive rating around it, right? A data science metrics would be around coverage and accuracy. So generally in the data science space, right, there are two broad metrics that we always use. There is coverage, there is accuracy. By accuracy, what we mean is if there is a prediction made by data scientist, by a data science model, how accurate was it? Was it right? Was it wrong? By coverage, what we mean is, let's say there are 100 examples given to the model. In how many of those cases the data science model is able to make a prediction? In 100 out of 100, maybe it is able to make a prediction on 70 of them. The rest 30 of them, it is not able to make a prediction because it's confused or it doesn't have enough confidence, all of that, right? So the coverage here would be 70%, 70 by 100. But within 70, maybe it made, let's say, 35 right predictions and 35 wrong predictions. Then 35 by 70 would be the kind of the accuracy, right? 50% kind of accuracy, right? So these are the models that a data science scientist would look to optimize for. That's one distinction that we need to keep in mind, and we need to differentiate and clearly define when we are trying to establish the problem, right? The fourth thing, while dealing with a problem like this, right, there are a lot of challenges that come in, right? Like, for example, this particular piece, there is a NLP exercise involved here, natural language processing, where we try to understand the grammar and kind of extract out sentiments and everything, right? So you have to deal with a lot of grammatical error, the use of English and everything when you're solving this problem, right? So how do we deal with these complexities? How do we build for it? And as a PM, you need to give a lot of inputs there. The second is how do you optimize for category nuances, right? For example, just to give an understanding when we are building this, right? If I take mobiles as an example, right, and mobile sells in multiple units, like it's a high unit category, right? So we get a lot of reviews. Visit any kind of mobile product, you'd find thousands and lakhs of ratings and reviews, right? So data sufficiency is not a problem there, right? So even if our coverage is low, let's say out of 10,000 reviews, you're able to extract insight out of only 5,000 reviews, it's completely fine because we have enough data. Even if some data points get missed out, it's okay as long as on an average it plays out well, right? But when you go to furniture kind of a category, right, where not each product doesn't sell like thousands of units, each product probably sells like hundreds or some units, right? So where data sufficiency at an individual product level would be less, right? So if you miss out on certain data points, it actually makes a lot of difference, right? So the kind of trade-offs you make and how do you handle and customize for different categories would be different. Second example, again, just to highlight the point, right? Like sound, if you think of this aspect, right? In a mobile device, like sound, if it is more, it's actually good because the volume is higher, you can actually hear it across and everything, right? But in an air conditioner context, if it emits sound, it's actually a bad thing because it's noisy, it disturbs your sleep and everything, right? So when a data science model is looking at a statement which says that the volume is high or the noise is high or whatever, right? It needs to treat it differently in a mobile device versus an air conditioner kind of product, right? So there are a lot of category nuances, and that is where, as a PM, you need to preempt or kind of pre-identify some of these nuances and educate the data scientist as far as possible so that he can take care of it, right? So that's on the problem definition piece. I hope kind of it demystifies some of the questions we had earlier. The second piece as a PM, right? So these are some of the key responsibilities that as a PM you need to kind of contribute in, right? How do you apply your domain knowledge, right? Because as a PM, you're much more informed. You know all stakeholders in the ecosystem, and you're much more informed, right? So first thing is, how do I identify the right feature set? That is one way you need to apply your domain knowledge, right? Just to give an example, there's a screenshot here. If you look at it, there's a Q&A page from Google Maps, right? Where someone is asking, can we take pictures in Mysore Palace? Is it allowed? Is it not allowed, right? Now, let's say Google Maps has built this feature. Their PM's objective would be to optimize the answer rate on this. How do I get answers faster and quicker, right? So if I have to think as a PM, how do I predict, uh, how can I get answers? There are multiple pieces. How do I identify the right users so that I can reach out to them to get answers? When do I reach them? What is the right time of the day where I can expect a response from them? How do I kind of nudge them? Like, what is the right messaging so that they feel like clicking on it and answering the piece? And then what is the channel? Do I reach out through website, app, or whatever, right? A lot of these pieces, right? So if I have to think about the right customer, right? Like, how do I identify the right people, customer set who can address this question, right? I might not just look at people who can answer, who have answered questions in the past or have answered questions in the Mysore Palace. Right? I can also think of maybe people who have written reviews for Mysore Palace. Maybe they've not answered questions, but if they've written reviews, I know that they have some information, right? Or maybe people who have visited Mysore Palace, right? So there are proxies. Even if you don't have enough data, you look at proxies which are substitutable. Or maybe people who use the Google crowdsourcing platform to contribute. So you know that they want to contribute. They don't have any problems or apprehensions in contributing. So you try to identify proxy data sets which can kind of give you some understanding of how to segment the users and how to predict their behavior, right? So that is one of the pieces where, as a PM, your domain knowledge comes into play. Second is, how do I handle data anomalies, right? So there's a screenshot in the end where I'm kind of hovering my mouse on, like, where there's a Flipkart returns page, right? Where while returning a product, you select a return reason, right? If you think about categories like clothing and footwear, many times people select the reason as size not being right? Because they tend to feel that if it's an easy choice to make, right? It's like, if I chase size, then the return will definitely get processed. And in many cases, it's just the default first option as well. So people just click and go, right? What that leads to is giving out a lot of noise, because that's might not be the right reason people are returning. It might just be the default choice, right? So how do we weed out that noise? And there are ways to handle it. For example, in this case, if a person is returning saying that the size is not right, and then orders places a subsequent order with for a higher size or lower size, we know that the intent was actually that the size was not right. Versus when we do not have a subsequent buy, probably it's a questionable data set, right? So how do we identify noise and build ways to deal with it, right? The third thing is, how do we make the right trade-offs? I touched upon that earlier. So I talked about coverage and accuracy, right? So I mean, precision is basically accuracy, right? Whatever we are predicting, what is the right percentage, and recall is basically in how many cases we are able to predict. And recall is slightly different. It's not coverage, but let's say basically there are 70. There is a data set of cats and dogs. There are actually 70 dogs, but as a model, I'm able to predict 40 dogs. Out of 40, maybe 30 are right and 10 are wrong. So 30 by 70. So 30 accurate predictions divided by the actual set of dogs, right? 30 by 70 becomes a recall. So out of the true data set, how many were you able to predict, right? That's the recall. And precision is how out of what you predicted, what is right. So often if you look at the curve that is at the bottom right of your slide, right? It's a declining curve, right? So when precision increases, recall kind of reduces. And generally, data science models have a confidence score attached to it, right? So as you tune the confidence score, as you make it more tighter, your precision would improve, but your recall would reduce. So you need to make the right trade-offs as to where do I draw the line? What do I balance out on? And there's an example, for example, on the bottom left of your screen, which is a quick reply from Gmail, right? Where you get a mail and it suggests certain kind of snippets on, we can directly kind of click and reply, right? So here, for example, right, the intent is not to be right. The intent is to make it convenient for the user, right? And you definitely don't know. It's hard to predict what are you going to reply, because our ways of responding are different, right? So the way you want to operate is you want to increase recall. You want to give all possible combinations, even if they're not 100% correct, but you have to give multiple different choices so that user clicks on one of them, right? So you optimize for recall. Even if it's not accurate, it's fine, because these are just suggestions. People can click and edit them, right? So you optimize for recall rather than you optimize for precision, right? The fourth thing where your domain knowledge kind of comes in handy is when we are evaluating the models that the data scientist has built, right? You need to question their assumptions. They would have made a lot of assumptions, right? And you need to test their models on both the happy cases and the unhappy cases, right? Otherwise, a lot of the times these remain in the blind side. You don't get to uncover them only later during the productionization phase, which is too late in the journey, right? And the last part is where, as a PM, you need to when you're working in an org like Flipkart or some mature org, right? A lot of things that you build can be applied just not in the context of your product, but many other sister products. Like I build a user profiling, for example. I can apply it in search, I can apply it in recommendations, I can apply it in somewhere else as well, right? So then how do we kind of make it more generic and not make it like specific to one particular use case, right? How do I build a generic model which can be deployed, can be used across each of these phases, right? So as a PM, you need to discover this use case and give the data scientist an insight that, look, we are building for this use case now, but in the future, I want to leverage it for so and so use cases possibly, right? So keep that in mind and build a generic solution, right? So these are some of the areas where your domain knowledge kind of comes in handy. So let's go for a poll now. I'll Sankalp, do you want me to publish it, or you can publish it for me?
I'll publish it.
Sure, thanks.
Sorry, I just got logged out of the meeting.
So let me publish it in that case. Oh, okay. I see one as published, but it says can't generate summary because no response is received. Okay, I have to wait probably.
Did the poll just go off as of now?
It shows in publish section, but it shows can't generate summary.
Exactly. I mean, I got logged out again. You want to take?
Let me publish the second poll as well.
Okay, you can do it from there. Yeah.
Yeah. Quick, guys. It's a very short question. Come on. 10 more. Okay. In the interest of time, I'll probably stop the quiz here. I think we've got enough responses. Yeah. So yeah, great choice. So yeah, the question was, let's go back to the previous slides. So can I? Okay, I can't see the first question. Okay, anyways, let's move on. So there are a couple of questions in the poll. I think the second one, I think most people answered it correctly. So the first one was, if you're talking about filtering out profanity, right? Profane content, which is like cuss words or everything from user-generated content. What do you prioritize, precision versus recall? Or maybe there are images which are, like say, not which are pornographic in nature or all that, right? So in this case, we would definitely kind of prioritize recall, because the intent is, if any of this content goes out, right, it leads to a lot of PR disaster, everything, right? So it's a very, it has a high leverage in terms of the stake that Flipkart as a platform has, right? So definitely go for recall. And even if there are cases where something is not profane, but it gets classified as incorrect by mistake, gets rejected by mistake, it's completely okay, because you want to, as a business, you want to err on the side where there are no legal repercussions of taking the right decision, right? So you definitely go for recall. The second one, which most of you kind of give the right answer to, is when they're dealing with law and court proceedings, what do you prioritize? Right? It's definitely explainability, right? So, like, if you think about our law, like, things people look for evidences, right? So you need, I mean, I don't mean to say that we need not be accurate here. It needs to be accurate, right? But when you have to make a trade-off in terms of, do I lower the accuracy a bit, but it has to be explainable, I think explainability becomes the right call, because whatever decision you take, you need to be able to explain and provide evidence against it. Thanks for that. I think most people got it right. Moving on, right? Sorry. Um the last piece which we want to talk about is a PM, one of the core responsibilities, right? How do we design the right user experiences, right? That's a critical piece, right? When we as PMs tend to think that it's a data science product, it's primarily a back-end product, and there's no UI UX involved here. Why do I need to think about it? But that's a very critical piece, and there are some elements of user experience. The first is, how do we capture user preferences? There was a question around this earlier, like, how do we solve as a cold start problem, right? There are multiple ways to capture user preferences, right? And many platforms do it very right. Like, for example, the first screenshot is from Spotify. When you first create a profile, it asks you, like, what are some of your preferred artists, right? So you try to capture preferences as explicitly as possible without creating a friction point for the users, right? So you need to design your onboarding experience to make that happen, right? Second is, allow users to update their preferences frequently, right? If you look at a screenshot, there is there down below, Sushant Singh Rajput, right? This is a screenshot from the Google homepage feeds that you get, right? Where based on your interest, Google recommends certain news articles. And if you don't like it, you can actually give that feedback and hide a particular story and say that, not particularly the story, but I want to stop getting any content from Sushant related to Sushant Singh Rajput, right? And now that everywhere he's there everywhere, right? Probably it's becoming a lot of spamming, and you want to stop consuming content from that, right? So you need to provide ways for users to also continuously share their preferences and update their preferences. And the third is, how, as users, you need to, sometimes you also feel that I need to blacklist something. I don't need something. I don't want something, right? Like an example from Netflix, where you can actually say that this is a title, or this is an actor, or this is a genre. I don't want it to be shown, right? And completely filter it out, right? So these are all ways of how do we capture user preferences in the beginning as well as on a continuous basis. That's where a lot of user experience comes in. Second is, how do we create the feedback loops, right? Because data science at the it's not deterministic, right? Lot many times when it's making a prediction, it can be right, it can be wrong, right? So you need to validate your output continuously, right? So the screenshot that I have from YouTube here, for example, it kind of time and again shows you a card which, and asks you, like, I showed you this video as a recommendation. Do you think it was a right recommendation? Did you like it? And if not, if you select a bad thing, it will ask you, like, why did you not like it? What was not right about it? Right? So create those feedback loops, continuously get feedback from users so that you can tune your models and products accordingly. And second is, your data keeps changing, right? You have to respond to new data, right? And whenever the model doesn't have confidence on, it needs to validate again. On the bottom right of your screen, right, there's a screenshot from Google Photos. So Google Photos, if anyone of you has used it, I use it extensively. I'm a fan of it. It actually does face recognition and classifies images into different user profiles, right? And whenever it is not confident, it tells you, like, do you see these two images as belonging to the same person or different persons, right? So it is, whenever it deals with a photo or an image which it is not confident about, it kind of takes that input and validates its output, right? So you have to continuously kind of doing that and continuously kind of do that. The next bit about user experience, right? I think because we talked about it, data science models are heavily reliant on what the underlying data is, right? So how do we collect data? And mostly, like, people start with, like, for example, there are public data sources I'll use, or there are some data signals that I generate internally, I'll use it and all of that, right? But many times, all of this data is not sufficient. You either try to create tag data, label data manually through some ops team or everything, right? So these two questions that come up to mind: how do we generate data on scale when we need it? And second, how do we maintain the quality of the data, right? The first thing, like, how do we generate data at scale? This is an example from Google Quick Draw. I'm not sure if you have looked at it. The screenshots on the right, Google Quick Draw. So it has like lot of drawings, like hand drawings of different objects, like there's a flight, there's a clock and everything, right? Let's say it has to like if you draw something and a model has to detect what object it belongs to, right? It needs to train on multiple hand drawings of multiple different people across multiple different age groups. Like youngsters would draw it differently, I would draw it differently, older people would draw it differently, right? So it has tried to gamify this experience. It has made it very playful. So you go to this platform, it will ask you key, it will give you 5 diagrams and it will ask you to draw it. And if the model is able to guess what you're drawing, then you kind of win or you lose. It's kind of gamifying the experience and making it very playful, right? But by doing that, you are actually enjoying interacting with the product. But by doing that, it is actually collecting a lot of data, right? So it is very intelligently kind of collecting data to train its models. The second I talked about was how do we ensure the quality of the data that we generate. I'll take an example from our past, right, where we were trying to classify content into separate categories to approve or reject it, right? And we were crowdsourcing it, right, like from different freelancers to kind of tag it manually. So based on our policies, do you see it as approved or rejected, right? And there's a likelihood that people just would select a choice at randomly, right? And they would not think about whether I'm spending a lot of time on that, right? Then what we started doing is if I'll give them 20 questions per individual, take these 20 reviews and try to tag them whether approved or rejected. I'll put in randomly 5 different reviews and tell them that where I know the answer. Out of those 20, 15 are where I don't know the answer and 5 are where I know the answer, right? So if someone is trying to play the system and try to randomly select, and they would get a wrong answer for those 5 sets, right? That is where I'm able to kind of identify the bad actors and try to take actions on them. So you build certain loops as a PM. This is one example which I was highlighting, but you need to build the loops to ensure that the quality of data that you're generating is good enough so that your models also learn on the right data. The next thing is how do we communicate effectively, right? A lot many times users need to know why you are suggesting something. Like Netflix does it very well, right? When it shows you certain recommendations, it will tell you they're recommending you this, but because you have liked so and so thing, you watched so and so thing, you have completed so many episodes of so and so series, right? So it tells you why we are recommending this. So it doesn't sound creepy, right? It tells you because you've seen this, I'm showing you this, right? And second, it also creates a thing that I understand how my user data is getting used, right? So it is very helpful in that way. The last part is a lot many times I hear a feedback saying that data science products like look very robotic in nature, and that is where as PMs we need to make them as natural as possible. And I can't think of a better example than Google Duplex. I think there was a Google I/O I think last year where they showed where the Google Assistant is able to do automated phone calls to a salon guy and book an appointment for on the behalf of me, right? And there are certain audio things. I'll just leave it in the interest of time. You can take a look at it later on, where it makes the interaction so humane, right? You can actually just Google for it and look about it, right? It will put words like and all of that, which makes it sound more human. It is able to react to what of questions that the person on the other side is also asking, right? The entire interaction is being done by a Google Assistant, but it doesn't sound like you're actually talking to a robot, but you're talking to a human. It sounds like you're talking to a human being, right? So how do you make it more human in nature? So these are aspects that as a PM you need to create so that users don't feel that I'm interacting with a machine, but I'm interacting with a human being, right? Uh, I think this is where we end the last section where we discuss certain industry examples to figure out some of the ways of building data science product. I'll pause for a couple of poll questions here. I'll just make it live. Let's see how you respond to that. Uh, okay, here goes the first one. Yeah, I think I'll stop here because even last time there were around 20-22 responses. So let's see. Most of you got correct. Yes, if you were to use, can we use AI ML to shortlist resumes for a job profile? Yes, we can definitely do it by understanding the education, the different professional qualifications which are mentioned in the resume, and matching it to the job profile and the needs of the job required. Right. Let's go to the next poll. Another question on whether to use AI ML. Okay, great. Thank you for the quick response. Okay. Yeah, it's great that all of you already know everything that I'm speaking about. So yeah, during a medical surgery, if you have to take life decisions on what to do and what not to do, AI ML might not be the best thing to do because of things that we'll talk about next, right? Because let's see what it uncovers. But ideally, you would not want to rely on AI ML to make decisions independently during a medical surgery, right? Okay, let me go back to the slide now, right? So we've discussed about how do we build an AIML product, what are the applications of it, and how do we uncover some of the hidden pieces around it, right? Now the question generally becomes, right, where do we use AIML? And can we use it everywhere? Or should we use it everywhere, right? Maybe not, right? Okay, someone has raised the hand, so I'll just pause here. I'm not sure how this works though. Sankalp, can you help me here? It showed me that someone raised a hand.
Sure. You're looking out for the doubts? Or what exactly?
I think it showed me that someone has raised a hand. Do I need to pause? Okay, I'll move on. Maybe I'll address the questions later on.
Someone is?
It showed me that someone is raising a hand. I don't know.
Okay, go to
Maybe,
participants.
yeah.
On top. Full nobody.
Sorry. Okay, maybe we'll park it aside and take it as part of the Q&A if that helps. Yeah,
Yeah, yeah,
just in the
sure.
interest of time. Sure. Okay. Um, so yeah, moving on, right? So where were we? Yeah, where do we use AI and where we don't use it, right? So generally there are some guiding principles, right? First is where things are recurring in nature and it's very difficult to and time consuming to do on a regular basis. Like I talked about content moderation, right? There are defined rules, but doing it manually and a scalable way, in a cost efficient way, is probably not existing today, so you can use AIML there. Second guiding principle is where rules are not enough, right? Where generally speaking there's a section on how to get started, right? Where we start with a manual way. Everywhere we start something manually based on our hypothesis or everything. When we learn more, we deploy rules like if so and so thing happens, do this. If so and so thing happens, do this, right? But at some point of time, the rules become so complex and rules become so many, either too many or too complex, that as a human being, you're not able to structurally organize them anymore, right? We talked about address intelligence. There are so many pieces in address intelligence who could in addresses which could go wrong. There could be wrong pin code. There could be wrong building names as given as reference landmarks. There could be so many things which could go wrong, right? So how do we incorporate so many complex rules, right? It's virtually impossible, and that is where probably data science kind of come in handy. Third is the scale of data, right? Manually, we can't deal with a lot of data. It's just like it becomes a cognitive overhead for a lot of us, and we don't have the right tools and techniques to deal with a lot of data. Like I talked about recommendation, right? There are millions of products, millions of users. The user preferences differ, and probably data science is the only way to solve for it, right? And the last one is where data keeps changing over time, right? Where uh, I have learned, I know, and it's manually impossible to keep up with the changing data and keep tuning our rules over a period of time, right? So where the data is changing over time, you want machines to keep learning automatically and changing how they respond to the data, right? So a lot of these cases, AI ML actually comes in handy. You need to apply them, right? Where not to use DS. The first one is where rules apply well, right? They work reasonably well. You have to understand that the gradient that I showed here, manual is probably the lead time to build it in research and development is the lowest. Rules probably a bit higher. Data science a lot higher. Right? Data science is very capital intensive in nature because you have to spend a lot of time in research and development, right? So wherever rules work reasonably well, you probably don't need to go into data science. Why make it unnecessarily complicated, right? Second thing is where there are mission critical systems where there are no scope of error or the decisions are very irreversible in nature. We talked about the earlier example in the poll, right? Where during a surgery, do you want to rely on AI/ML to make a decision for you? If you don't take the right decision, probably it could lead to a fatality of the patient, right? So you don't want to rely on AI/ML to make the decision on behalf of you. It can recommend, but the decision has to be taken by a manual doctor or someone like that because the decision is irreversible in nature. And third is where explainability is crucial. Most data science models are not the output is not explainable. It deals with so much of data because the sheer nature of the data, it will give you an output. That output can be 90% plus accurate, but if you ask it like why are you generating the output, it will not be explained. It will not be able to explain, right? So wherever there are need to, we talked about the earlier example of law proceedings, right? Where you need to provide evidences, we need to convince stakeholders why this decision. Probably data science or AIML is not the right way to go about it, right? Moving on, I think like we discussed earlier, we'll take one concrete example and kind of walk you through how AIML comes into play, and we'll take recommendations as an example, since it's like widely known that there is one of the core problems that AIML solves for, right? Now, why is recommendation solved by AIML, right? So the complexity exists because one, there are too many choices, too many products, available choices, and you need to deal with all of these. And second, there are too many users with varying preferences. All of them are different. So it's a matching problem in a way, right? You need to match the right products to the right users, or right content to the right users based on which domain you're operating in, right? So the scale of data is huge, and that is why you need AIML. So, when it comes to building recommendations, right, it's kind of personalizing the experience, right? When you start off at any platform like Netflix or anything, right, they so it's the same content or same homepage to everyone, right? But then over a period of time, they realize that it's not working, right? You might like that content, but I might not like that content, right? So then you go to the next level of personalization, which is like from zero personalization to going to a cohort level personalization, where basically you don't do a user level personalization, but you say that for Indian customers, I'll be doing this. For US customers, I'll be doing this, right? So you're looking at a user cohort, right? The reason you go to a cohort level is there are certain common preferences. There are some certain commonalities in these user segments, right? So you build for that cohort, and you have certain data sufficiency as well, because you can aggregate data over that audience, right? And it's easier to build as well. But over time, when you try to optimize it further, you go to a user level personalization, right, where you basically optimize for each user, right? Even in the Indian users, you try to make it different for me, make it different for my wife or whoever, right? And the last level is like when you go to user cross context level, right, where even for me, the content that I see in the night when I'm about to sleep might be different than the content that I see in the afternoon, right, after food or everything, right? Like maybe we have learned over time that I'm consuming different kinds of content during the different times of the day. So the personalization now happens at a user's cross context level, right? So there are different levels of personalization, and every company kind of goes from zero personalization to that level over its journey, right? The second level is, what do you personalize for? There are different aspects which you personalize for. One is language, like English versus Hindi or whatever. Then there are content types. Someone likes long form movies, someone likes short movies, something else, someone likes certain genres and everything, right? So there are different dimensions of personalization. Now coming to how do you build that personalization, there are data inputs, right? So typically speaking, there are two sets of data inputs to every data science model. There are implicit signals which you generate over time, like browse and watch history, like what am I browsing, what am I watching, what content am I completing, how much, did I like it, did I not like it? All of those are implicit signals, right? I'm not explicitly asking the user, he's just doing whatever he needs to do, and I'm capturing and deriving insights out of that. Second is explicit signals, where I, like for example, the onboarding experience, right? I explicitly ask him, can you tell me which movies you like or which actors you like, right? So using a lot of these data points, you generate the recommendations, right? Similarly, we talked about context. Context also differs. Like there is user level context, there is session level context, there is day level context. So there are different granularities of context, right? Today, maybe we are 15 days away from the Dasera season. So I want to make a purchase for Dasera. That is kind of a broader context, right? But within that context, maybe today I need a grocery, right? I need to order grocery and I go to Flipkart and search for, like, say, tur dal or whatever, right? So my broader context, I want to make a purchase for Dasara. But today, within the session, my context is to buy grocery, right? So the context also differs, right? I might come back tomorrow and continue with my purchase or browsing behavior for Dasara, right? So you need to understand different contexts as well. And the recommendation engines understand and demystify this piece as well. The last is how are recommendation engines built, right? Multiple tools and techniques which are used. But two common things that generally companies across industries use. One is collaborative filtering, where if you look at the screenshots on the top right of your slide, right? What do you mean by collaborative filtering? You try to find commonalities between user behavior, right? Where uh, you and me both have watched and liked these same 5 movies in the past. So I think that you and I are similar kind of personalities. So if if I watch a sixth movie, you start recommending the same sixth movie to the other user as well. So it's collaborative filtering. You basically identify people who are similar to each other in their behavior and everything, and then kind of carry over their preferences to each other. The second is facet similarity, where basically I watched certain content or liked it, you know that then you understand that probably I like this genre, I like movies from this particular actor, right? The facet here is a genre, or actor is a facet, right? So the different facets of a movie, you identify what are my preferences on each facet, and then identify what is the other content around that facet, and then recommend it. So these are the top techniques that are generally used in the recommendations platforms that we build, right? And that is using all of this. Netflix kind of gives you that 98% kind of match percentage today, right? It wants to make it as accurate as possible, right? Um, so this was a core example of how we use AI/ML. So I think this is my last slide, right? As a PM over my DS journey, right? I faced a lot of challenges, and I'll kind of highlight what are some of the challenges that we face in an organizational context, and what are my learnings has been. How do you kind of go around it, right? So first is one thing we all of us need to understand is data science is non-deterministic, right? Engineering systems used to be very predictable, very deterministic. You write something, there are like, they think of like coding, right? It's like if else statements, if this else this or whatever, right? So there are predictability attached, right? So people are used to that. Stakeholders want that kind of predictability. They feel more in control when there is predictability, right? But data science is probabilistic in nature. There can be an output, there cannot be an output. If there is an output, it can be right, it can be wrong, right? So stakeholders need time to kind of get used to it, right? Second is, when you're starting off building a data science product, it's completely kind of more near to impossible to predict, will I be able to make a 5% jump in conversion when I am able to solve it, or will I be able to make a 2% conversion, right? So predicting the extent of success is also very kind of difficult in the beginning. So where as a PM, what we need to do is, one, kind of start small, right? Never kind of spend all your energy in the beginning. Identify your most critical hypothesis that you need to test, right? Which is the most critical part of your product, and test it out. Build a POC around it and test it out, and gradually keep testing one hypothesis one by one, and keep building one by one, and try to scale it up, right? So you don't invest everything at one go. You invest small, reap its return, convince your stakeholder that is working well, and then keep investing, right? And 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 second is, you provide some levers to the stakeholders to override things, like as a data scientist, you build fallback loops, or you build feature flags. Let's say if they feel that it's not working, they want to switch it off. You have a way to turn the data science model off, right? So you give some certain amount of control, not always, not everywhere you need it, right? It might not be the optimal thing, but in many very mission critical systems, you might want to give stakeholders some kind of a control on where to use, where not to use the data science, or need to override the output of the data science, right? That is where they get comfortable with dealing with data science outputs. The second thing is, a lot of times you face this business resistance, right? For example, if I'm trying to build something, right? Should I build it in-house? Should I buy a company which is already having a build product around it? Again, this is probably relevant for many senior level guys who are working in product management, not so much for entry level PMs. But again, you face this challenge, right? Do you build it? Do you buy a company? Or do you license it? Like someone has already built it, I get into some kind of a collaboration model, which I pay them and keep consuming their APIs, right? So it depends on multiple factors, right? One is, what is the time to market? If there is something sensitive, you want to launch it as fast as possible. You don't want to lose time. Obviously, building takes a lot more time, right? Buying also takes quite amount of time. You have to negotiate, you have to sign a contract and everything. And license is easy, right? So probably you'll err in favor of license. There are things which are strategically important. Some data points you don't want to give out access to other companies, or you want to build that expertise in-house, because tomorrow in the future you can actually leverage it for multiple other use cases. So that is a strategic importance for you going forward, right? Those are cases where you would want to build internally. Or maybe if you have both strategic importance as well as sensitivity to time, then maybe you could go for a buy decision as well, right? Then there is a question of skill availability, right? Do you have the data science people or the right skill sets to actually help you build that? If you don't, then you need to spend time in recruiting the right people, which will again take time, right? So a lot of these business decisions as a PM, you need to evaluate and take the right decisions in favor of business or customer, that whoever you're optimizing for. The third challenge that you face is, which I talked about in details earlier, is data science models lack explainability. So you need to kind of educate people around that, create transparency, and allow some scope for manual overrides. The last thing, which as users we generally are concerned about, right? All of our data is is out there in the open, it's no more secure, right? How do we deal with it? Then people won't be wanting to kind of share the data with us, right? So I think there are a few things that we need to do. One, give the control to the user, right? The user should have ways to kind of prevent the access of data, or stop giving access to that data. Second, you need to start anonymizing the data, right? So that you can derive insights out of it and use those insights, but you never know what is the data which is pertaining to one particular user. You're anonymizing for it at a broader level, right? Third is, you need to build organizational firewalls, because you have that data. All of the data is stored in your systems, in your database and everything, right? How do you prevent anyone and everyone from getting access to that data, right? How do you build restrict access? How do you build the right organizational firewalls to kind of restrict access to that data? And last is, whenever you're seeking access to some data from a user, communicate continuously as to how are you making use of that data, right? What are you trying to solve using it? How are you optimizing the experience for the user using it, right? So if you look at Google and Netflix and everyone, like, they allow you to kind of turn on and off in terms of what data you can allow them to keep tracking, or you can actually download a copy of the data that you have. So all of that, so it gives you some levers to feel in control of the data. So I think those are ways to kind of, and it's a very continuous exercise. You need to continuously do a lot of these things to build trust in the user's mind, so that they can get comfortable with sharing the data. And so these are some of the challenges we generally face as PMs on a regular basis, and we need to kind of find ways to work around it. I think this was my last slide. Before we conclude and go to Q&A section, there is one last poll which I would want you to kind of answer. I'll just start the poll. Yep. It should be a very simple question. Let's see. Not a single response yet. Is it because of the length of the question? Awesome. Come on, I'll give maybe 10 more seconds. Okay, I'll stop here in the interest of time. Let's see. I think most people have, I mean, not most actually, everyone has got it right. Awesome. You're a fantastic crowd. Um, okay, so I think the question was around, let's say the data scientist built a model which is like very accurate, but when we launched the product, and it actually didn't make a lot of sense in terms of business metrics. If you remember, in one of the earlier slides, we discussed about uh, business metrics being different and data science metrics being different, and this is a kind of a very clear example of that. Data science metric is very good, it's coming out to be very good, but the business metric is not working in favor, right? Then what do you do as a PM? If you look at an elimination principle, you can definitely not launch that feature. You can't launch the feature at all. That option is out of your scope, right? Because uh, you have to understand that you can't build something which is against your business, right? Or against your customer. Then the question comes next: do I kill my feature, or do I reimagine the feature? In most cases, it's your call, right? In most cases, it's not an easy decision, right? Where you need to go deeper into the data and understand, right? Why did it not lead to a rise in conversion? Again, build your hypothesis. Maybe you would have missed some hypothesis in the beginning, right? That is one. Second, segment the data and look at different user segments. Maybe there is a user segment which where it led to a rise in conversion, increase in conversion. There was a user segment where it led to a drop in conversion, right? So think of, can we launch this feature only in the segment where it made sense, right? So build your hypothesis, segment the data further, and validate your hypothesis in each of these segments individually. Third is, if none of this works, right, try to think if the feature can be positioned in a different way, right? In a slightly different way. Maybe you can use the same model that you built in a slightly different way and position the feature in a much more different way, right? So think about ways where you can one, uncover more hidden truths about why the feature didn't work, and accordingly make the right product calls in terms of whether to launch it, how to launch it, and when to launch it, right? Yeah, I think this is what I had from my presentation. So thanks for listening. I'll kind of stop here and go to the Q&A section. Sankalp, so should we just go over the doubts one by one? How does it work?
So, I believe you've answered all the queries in the doubt section.
Not yet. I'll have to go through it. Like
We
there are
can just
few.
take up some queries out here. With the
Sure,
interest,
sure, sure,
we
sure,
have 10 minutes left, so we
sure,
can take up queries for the next 10 minutes.
sure. I think the first question was how to convert a business problem to AIML problem. I think I've already answered that. I'll also give it a miss. The next thing is talking about user profiling. I think I answered that as well. If there is a problem of concept floating and model performance degrades after some months, does at the later stage activity of retrain test redeploys manual in large scale environments? What's the automated way to do that? Mm, not very sure about if I got the question, but I'll just kind of break it down into a couple of things. One, uh, how do you identify the performance has degraded? And second is when you identify it has degraded, how do you
Between.
retrain?
Hello.
Sorry. Yeah.
Hi, we were not able to hear you. Could you just repeat that, please?
Okay. I think the question is around when do we, can you hear me now?
Yes, we can hear you.
Okay. I think the question, I'll just break down the question into two parts. One, how do we identify that the performance of a model has degraded? And second is when we identify, how do we react to it and retrain and deploy it? The first part, how do we identify what is degraded? I think there are automated ways to do it, right? As well, if you can identify the right metrics and keep tracking those metrics, create the right alerts and dashboards, it's very easy or relatively easy to kind of identify when the performance is degraded. How do we retrain and redeploy? In there are different nuances, right? In many cases, you need to retrain the model and kind of redeploy it and do it manually using data scientist self. But in many cases, it's also like a neural network based model, right? They are self-learning in nature. They automatically kind of react to the changes in data, right? So you need not manually retrain, test, and redeploy, right? But and having said that, you notice that the performance has degraded, right? So you might have to do certain tweaks in the data. Maybe you need to introduce a new feature set which was not relevant till now, or make some certain changes because the business context has changed, right? So in most cases, it will need some manual intervention, even if not, even if there is no need to manually kind of completely retrain it from scratch. Hope that answered your question. I'll just resolve it now. How do you know what are the benchmarks for your product in your industry? For instance, the number of weekly active users might be different for a food delivery service vis-a-vis a book my show, which is fair. I think this is, uh, I don't think this is in the scope of data science per se, right? This is true for everything else, right? Where basically, if I look at the example, right, you're kind of comparing weekly active users, and it's not a very one-to-one comparison. There are different industries where behavioral patterns are different. In social networks, I might actually visit like multiple times in a day, but if I have to talk about, like, for example, let's say an e-commerce platform like Flipkart and Amazon, I can't expect the user to visit like multiple times in a day, right? It's not right to benchmark companies across industries. There, you as a PM, you need to understand these nuances and try identify the right benchmarks. Second, how do you identify what is the benchmark? I think what you have to rely on is some amount of secondary data which is available in the market to kind of identify whether you're in the right zone, right? It's impossible to know that the very precise number for every data point, right? But you can always know ki at a ballpark level, how am I good? Like, am I close to what my competition doing? Am I like maybe 10% very bad compared to my competition, or am I too good compared to competition? I think these are nuances as you keep tracking your industry, you can actually develop some knowledge through the secondary data insights that you get. And also, a lot many times as PMs, we need to be well networked with our ecosystem, right? Where we need to know PMs and kind of talk to them about some of these things, get their insights, and kind of try benchmarking. I think you have to rely on a lot of these data points to make your hypothesis, right? Next question, suppose if you're in a review section, if there is option to review a product using voice or audio, how easy it would be to get tracked using data science? What do you mean by how easy it is to get tracked? I don't know what you mean by get tracked, so I'll just give it a miss. Maybe you can reframe the question and put it again. who finally takes the final decision, PM or DS, that the model is accepted from a business point of view? It's definitely the PM, right? Like I mentioned in the last, that is exactly the question I was trying to address through the poll question. It has to be the PM because he knows the business and he's the sole call taker. If he says a no, then the data scientists need to react, need to respond. How do we make it suitable for business? But the call lies with the PM and the leadership. Uh, I think. Okay. I'll give it a. I don't know what this means. Do rules and DS go hand in hand? Might be a split of 50. Definitely. I think you got the point here. And in most systems, that ways works in that way, right? It might not be solely a data science kind of model, right? Like I mentioned in my challenges and learning slide as well, lot many times you need to allow stakeholders to do manual overrides when it's super critical, right? And similarly, your product can be a combination of certain rules and certain data science models as well. It's very well likely. And what you have to keep in mind as a PM, right? You are not solving for the accuracy of data science model. You are trying to solve for a customer need or a business problem. So whatever gets you there in the best, most cost efficient, most optimal way, I think you take that route. With respect to user versus session context, please clarify how do you define a session? Log in to log out, time based like an hour. I think it doesn't matter, right? It depends on your use case, your industry, your company, right? Whatever makes sense to you. It depends on the behavioral patterns of your industry. Maybe content, for content, a 2 hour is a session. Maybe for an e-commerce platform, a buying decision typically takes 2 to 3 days, or 2 3 days is a session, right? Depends on the industry, the company, the space that you're operating in, and you need to define what it means individually for your use case. um, I think this is the last question. Few business metrics on the basis of which either we accept or reject the feature. I think we touched upon that. In most circumstances, right? I think the business metrics also differ across problem statements. In most cases, if you're working on customer-facing products, it used to be engagement or conversion. By engagement, I mean, how much time you spent on the platform, how many times you interact with the platform, how many times you revisit the platform, all of that, or how many times you contribute to the platform. By conversion, mostly like how many times you buy a product, or how many times you complete a recommendation in YouTube, or whatever, right? So, or how many times you click on an ad, or whatever, right? So the business metric differ based on what feature and what product you're building. But if it's primarily mainly around engagement and conversion, right? But also, like, let's say you're building some automation product using data science. Like we talked about content moderation in some details, right? So there, the intent of the business metric that you're trying to solve for is how fast I can moderate it and how accurately I can moderate it. So, and what is the cost optimized way of doing it? If I do that moderation manually, a person maybe spends 15 minutes or 15 maybe seconds on a particular review, right? So based on how much we pay that guy, we can compute like what is the cost of moderating one piece of content. So cost optimization can be one of the metrics. So the business metric entirely depend on what you're trying to solve for, and it's not like there's no rule of thumb there. I think I have resolved most of the questions. If there are any additional questions, feel free to put it in the doubt section. We can maybe stretch for another 5 minutes to address those if required. Sankalp, over to you.
Cool. So, guys, with that, we've come to an end to the session. I believe, with the interest of time, we won't be able to take up any more questions here. But if you have any questions, please post them in the discussion forum of your program. With that, I'm launching a feedback poll. Please share your valuable feedback. Also, at the same time, Ram, as the learners fill the feedback, do you have any concluding thoughts that you want to share with the learners?
Yeah, definitely, sure. So I think thanks for listening very patiently. I hope some of the questions that you generally have while trying to move into a data science career or working as a PM, I was able to resolve. Uh, 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 so just what I would just before parting points, right? I think what you need to keep in mind is at the end of the day, you're a PM, right? So you need to solve for the business or the customer. You need to understand the why part of it. Those are things you optimize for, right? The more you know data science, it helps you because you can effectively communicate and work and collaborate with data scientists. But at the end of the day, you are a PM, right? I think those are my parting thoughts, and it's been great kind of delivering this. Thanks, and all the best of luck for your future.
Ram, and thank you so much for delivering an insightful session too. With that, thank you so much, guys, for attending the session on on a Sunday afternoon. Pleasure hosting the session for you. Yeah, as I said, please post your questions in the discussion forum, and our TAs or your peers will be more than happy to get that resolved. With that, thank you so much. Take care and stay safe. Thank you so much, guys.
Thank you.